So I'm going to be running a Milodon part number 31003 oil pan. It's got kickouts on it, lots of little trappy doors in here, little swingy things. Makes a lot of awesome noise. Oh, pro tip, don't call them up. This is half NPT, half-inch NPT. I had to call them up. It had a recess on it. I thought it was an O-ring. I don't know. Anyways, that's what it was. So on this oil pan, they have a windage tray that you can buy from them with two gaskets. I didn't want to go that route. I wanted to have a nice, one of those ones that you can just unbolt and bolt back on. No big deal. But then I noticed that it's missing a few things. Huh? So it's missing that. So when I put it on here, I noticed that I could get, where's my little hole? There we go. I could get to the holes there, but it was missing those. So I was like, oh, no big deal. I'll just drill them out. But then I'm, missing this whole thing. Then I got this, this steel thing there. So then I went and looked up a truck. This is for a 2005 1500 with the 5.7 Hemi in it, which is the same stroke as the 6.1. It's got the extra holes on it, but it doesn't, as far as for the kickouts here, it doesn't have the boss for them. It does have some sort of release for them, but it's, it might run into it. But the only problem I did see is right here. Now on the oil pan, it follows this course where the block goes over here. So there might have to be some yucky pucky right here just to seal the pan to this, which kind of defeats the purpose because the whole point is so I can take the oil pan off without sticking to it, but it is what it is. But I'm going to run this pan, this windage tray, pan gasket, so on and so forth. But this is the one. Here's the part number. It is OS30750R. That's the one I'm running. Anyways, yep. And then we're gonna do some math. We're gonna math out these holes here to see if I need to take the top off that, cut it open, and weld on a different screen, or possibly just drill these out. I'm not really sure what I'm going to do here, but I'm going to do some math on that and make sure that all these openings equal more than the diameter of the hole there. Alrighty, that'll be the next. So I measured the diameter of this hole, one of these little holes. I did about 10 of them, so then I just took the average. The average was about 91 thousandths. Then I did the ID of this pickup tube. So hole diameter was 091, and to get the area is pi r squared equals area. So radius of that which is basically diameter, divided by 2, that gives you your number. Then pi times the radius squared gives you 0.0065 inches squared. I counted the holes. There was 13. There was 9, but there was 13 rows of that. Then I counted the other one. Now these are only the full holes. I'm not counting the half holes. These are just the full ones. So there's actually more. And then as it tapered down near this end down here, right in here, I got obviously just progressively smaller. 9, 8, 7, 6, 5. They gave me 35. Gave me a total of 152 holes. Holes, 152. There's my area. So that gives me a total of 0.988 inches squared for an area for the pickup screen. Then I want to do tube diameter. Tube diameter was 0.759. Same type of deal. Pi r squared equals area. Half of that is your radius. Pi there gives me 0.4524 inches squared. So the area for the tube is 0.4524 inches squared for an area of the tube. So we're already better, but how much better are we? Because remember, you're going to have flow likes to go through the center of something, not necessarily in the actual, it wants to go through the center, not up against the wall, because that's going to be friction. So you have a whole thing with closed orifice and type of deal. I'm not going to go there as far as pressure drop and so on and so forth. So what I did is I took the tube area, and there's that, the area of the screen, there's that. So then we get 0.45789. Then this is just how I do math. I take 1 minus that, and that gives me 0.54211. Since we all know the percentage, just move the decimal place over 2 points. 54.211% more area on the screen, which is good because I could go into a big, long, math thing about closed orifice. And like I was just saying, again, I'm not going to do that. But I was looking for 50% more area, and I'm over that. So I don't need to cut open this and do that like I've done in the past on other engines. There's plenty of room on this one. So yeah, I'm going to go ahead, and the next time you see it, I'm going to be putting, actually that one, I'm going to be putting that one on and going from there. Alrighty. So here's what I got. So that way you can kind of see what I'm doing here, is that I had to massage it here because I have studs right there and they were hitting. So what I did is I made it so that way, if you see the holes are slightly lined up, that's where it hits now. So it's got plenty of room in there, and that would just cause a noise that would just be annoying to me. And then you can see here how it lines up now. All the drain back holes are exposed. So, and there's no holes on this side, which is good for windage. I did have to cut these down slightly here for the studs and right in here to clearance all that. And yeah, so this thing is currently ready to go on. I'm going to go and give it the last little cleanup. And then I'll show you, I'm using factory pan bolts, but I had to cut them down also. I'm going to go and clean this up one last time, and we'll be putting oil pan on. Here's another little pro tip that I do. When I put the room main seal on, I put a little yucky pucky in there to kind of cover up the little cracks and whatnot. But then before I put the oil pan on, I take a razor blade and I cut obviously this direction. And so then I'm going to cut that one that direction, and it'll give me a nice clean edge like that. And then I just put a tiny little bit when you put the oil pan on. And then I'm going to do the same thing here. But this one actually goes in, it doesn't stick up. And this one right here, it goes in, it doesn't stick up. So, yep. Alrighty, we're going to put an oil pan on. Yay! Obviously, this is the reason why it takes me so long to build an engine, is that I take my time. Take your time, take your time. Double check, triple check everything. And this is why I do this. All right, moving on. Here's what I did for pan bolts, is I took a stock pan bolt, which looks like that. And then I just ground the tip off and then just tapered it. And then obviously I cleaned it, hit it with a little WD-40 so no rusty. And that's how I'm getting them all in. Putting all the pans in like that. So yeah, we're going to get it done, tighten it down, and flip this thing back over. Whoa. There it is. So they call for 9 foot-pounds, 9 times 12, because I do it in inch-pounds. It's 108 inch-pounds, since I got a nice little, snappy, inch-pound gauge. Put it on, so went around a few times, and that's good. And here is the momentous occasion, the really big. So I get to turn this little crank here. Oh, there it is. Little drip. And there it is. It is actually turned right upside. There it is. And I've blocked off this hole already. I just tapped it out. I put a thread in there. And I'm going to drill it out and put a little bigger one in there. And that way, if I ever decide to put, if I decide that I want to have, some water, I can just thread it in. But I'm going to have a whole bunch of stuff up in here that I'm going to do on another video of this engine. I'm not going to do it tonight.